All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanagh, here in year 18 of DM Radio. And I'm so excited to have an old friend back online. We've got Mark Madsen of ThirdNature, and we have a couple folks who are going to talk about Matterbeam, which is one of the coolest technologies I've come across in a long time, in part because they took such a creative approach to solving a previously intractable problem. And we've seen in the data world, for example, that we kind of get into these habits of building big things. And I make analogies to the real world of very large buildings. And so, like in New Orleans, in just the recent few years, they built a new VA hospital, which is this absolutely massive, honking, huge structure downtown. Absolutely massive. The air conditioning bill must be through the roof. You're talking millions of dollars to keep this thing air conditioned. And it's like, why did we do that? Why didn't we spend that money on MRI machines, for example? We don't need these huge facades anymore to administer healthcare. But there's an old mindset, and of course there are contractors who have to get paid and politicians who get involved. But in the data world, well, what's the analogy? It's the big data warehouse or the big data lake. And you have to wonder, did we learn any lessons from the data warehousing world as we moved into the data lake? And then, of course, there's the lake house architecture. And it's like, all right, guys, what are we even talking about now? Well, the folks who know something about that are Mike Kowalchik of Matterbeam, and also we've got Josh Pendergrass calling in from Synckly. It's actually Broadmoor's Synckly company, and let's dive in. So I'll give my take of what I think you've done here, which I think is very very interesting. So Matterbeam is focused on pulling in data from what are called write-ahead logs, and so every enterprise system of worth its weight in salt will have this write-ahead log. It's designed to persist data just in case the system crashes while it's in the process of writing to a particular system. So they said, hey, let's just pull all that. We'll get collectors. We'll pull all that into this big append-only log. And then they built a time machine that lets you go back, roll back in time, and sort of emit the data in whatever form you want. So if you want it for a graph database, fine. If you want it for a relational database, fine. If you want it for a vertically oriented, like a column oriented database. Fair enough. Whatever you want, you could do at the last minute. So as opposed to the old, if you build it, they will come argument, no, we're just going to create this giant append only log and then let users do whatever they want with it to do these last mile transformations and get data products on demand. I heard that. I was like, that is freaking cool. That is like really thinking into the architecture of how these systems work and finding a clever way to enable the possibilities down the road because you never know what's going to happen. And I'll say one last thing, just because this quote is in my head. We had a guy on the show about a month or so ago. They built a whole new ERP system. Sandeep Chopra is his name, from Everest Systems, and he said something that blew my mind. He said, "Why did we go with agile in the first place?" And he said the reason is because no one knows what the customer wants. And so you just want to build something small and get your MVP and then be able to vet against the customer demands and kind of move incrementally out from there. Well, it's kind of like Matterbeam figured that out. And they said, look, we don't know what our users are going to want. We don't know what use cases will be down the road. So let's just allow them this quick and easy way to build data products on demand. So with that, I'll throw it over to Michael Kowalchik. Tell us what you built and how it works.
Yeah, no, that's a great sort of synopsis of it. One other way to think about it is, I've been in engineering and data for a long time, and I always used to say that a lot of the systems that we work on are almost like fractal, right? You
Mm.
work on something at a CPU level, and then you have distributed systems, and a lot of the same problems exist at the different layers. They're almost like look very similar. And that was one of the inspirations for Matterbeam, frankly, which is if you take, like you said, most of these relational database systems or any database system, frankly, usually internally it has this split of between how it writes its data and how it reads the data. And so to get data in fast, to make it durable and write it and all those things, you have the write ahead log or the commit log, depending on your system. And so you write all of that stuff, and then internally, what the database does is it turns that write-ahead log into your B tree in a relational database so that you can do flexible query. It turns it into the key value store like things that make your indices and things like that. So all the different ways you want to read data inside of the database are basically materialized by the database internally off of this log, right? And this is also how read replicas and things work. You ship the log or whatever. But one of the inspirations was, well, what if you were to take that idea of this read write split and this write ahead log and blow it up to your organizational scale. And I have to give props to Martin Kleppman. He was one of the people that inspired me. I had been thinking about these ideas, but he really crystallized them. He had a talk called "Turning the Database Inside Out," where a lot of these ideas came out.
Hmm.
Um, but it's basically doing that, turning this idea that normally is like an internal detail of how these databases work, and turn it into a first class citizen of your organization. And now your B trees or your indices or whatever are actually full systems in a Matterbeam view, right? You make a relational database off of this. You make a graph database. You make a document store. You make these other things. And so it really does unlock a lot of incredible flexibility. I got to sort of prototype this at the company that acquired my last startup, and I really saw it completely transform how people engage with data, how they use data, how they even think about using data.
Hmm. That is absolutely fascinating. Let's bring in Josh Pendergrass. You're out there using this technology, and you've had a few aha moments along the way. I think you had mentioned before that at first you didn't fully understand what was going on. You just wanted to solve some problem, and then you were like, "Wait a minute, I now see what they're doing." Do you want to talk about that aha moment and what it was?
Yeah, so Mike talks about the immutable log, and at first I was like, that seems great. I don't know that I'll need that. It's more backup related, right? So I just need to move data from here to there for right now. But then as we got into it, the whole ability to replay something to any point in time or to sit there and transform it and emit it to multiple different sources, the hub and spoke sort of thing. It just the light went off on like, oh my gosh, as long as we're collecting this stuff, I don't have to worry about, setting a point in time where I want to connect this, and if I want to change anything, I've got to like go redo the whole thing, right? I can literally just make a change and it'll emit what I need and go exactly where it needs to go. So and the other thing is like, the key, once we figure that out, we decide we're going to dump all of our data in here and have it just always collect everything. And that way I can replay anything I want. I can create any report I want from whatever source I need. And so yeah, it was the immutable log now. First was not a big deal for me, and now I'm like, this is a game changer. This completely revolutionized how we do things.
Yeah, that's so interesting. And Mark Madsen, I'll bring you in. You've taught me more about database than just about anyone else I know over the years. And you know all about fine-tuning databases, which ones are better for certain use cases. And this approach I just think is so interesting because it's like it's going a layer deeper and enabling these last mile transformations to develop whatever you want. So, because again, you don't know what the customer is going to want. So, to get them halfway there such that they can just jump in and do this last mile transformation, that strikes me as pretty compelling. But what do you think?
Yeah, I think actually I would go the other direction. You said it goes a layer deeper. I'd say it goes a layer higher. Um, because the idea is that, you still have these databases and things doing their work, and we've always had them. And what I like to go back to the history of a lot of stuff we have and how we got there and why. And what's interesting is that if you go back to the mid 1980s, before and when the term data warehouse was coined,
Hmm.
we had big piles of production copies, but very specifically engineered for reporting. They mixed the two use cases. There was no separation of concerns. And so everything was always collect and smush. And uh, and then you had your rectangle, and then you went off and did your report, which is ironically no different than today's, pipe my lake to Power BI and Tableau things where people do what Michael criticized as the point-to-point pipeline. Every report is an object, is a data product, whatever you want to call it, is a pipeline. That is a non-starter and a non-scalable model. And he focused in on that, I think, as design principle. But the other part about moving up is back in that 1980s, if you go back to the very first paper which ever used the term data warehouse, it actually separated out collection from integration. And what we're doing here is we're saying, look, the old architecture was, had this for reasons of convenience, for ease, for cost. We did something different and we put it all into one system box when we shouldn't necessarily have done it that way. And inside that data architecture was collection use as two separate domains.
Mhm.
And what we're talking about here, from the description of what Josh is doing and from what Michael is talking about from a tool perspective, is how about we separate those again? I'd kind of like to hear, your guys' opinion on that, because that's my observation.
Yeah, I
Yeah, Michael,
think
go ahead.
yeah, I think that's a good observation. I think it's trying to separate those concerns because I think a lot of this trying to smush everything into one system is a little bit historical and it's not really serving us now, right? One of the reasons we have the lake house now, right, is because everyone went in all on the warehouse and they're like, oh, actually, this is terrible for distributed compute. Or the other side of people who went all in on Databricks or some distributor or Hadoop or some distributed computing. And they're like, oh, this is terrible for warehouse jobs. So now we need the new one giant system to smush everything into, and we'll call it the lake house. And it does either okay, but not great, right? I'll give you props too, Mark, that one of the other things, I mean, 10 years ago now, that inspired me a little bit in Matterbeam was one of the talks you gave at a GoTo conference where you made this specific, I mean, the talk kind of goes in a lot of different directions, but you talked about making explicit trade-offs, right? There's no one system that will do everything, right? You're going to make trade-offs on how your physical schema is and your logical schema is and how you represent the data changes what you can do with it and your sort of write and read characteristics. And so what if you could move those trade-offs upstream, move left, shift left, or whatever, and so you don't have to make those trade-offs right away. You could do them at the moment of need and put them into those systems and take advantage of the best of breed thing at that time. So I also like to look at the history of things, and there's so many brilliant ideas that have been woven through the history that either fall by the wayside or people rediscover and they're like, oh my God, I discovered this new thing. You're like, actually, that's that thing from 1985 or
Yeah.
1990 or whatever.
Yeah, I totally agree too. I think of it from a time to implement, right? So if you don't separate concerns, I've got to think about all the starting points, all the stuff in the middle, and then getting to the end. Whereas if you separate those, the collection of these things, that data usually doesn't change, right? That's kind of the same. But what changes is what comes out the other end. So if we separate those concerns, I can focus on just the last part of it. And we've noticed that where things are much easier to implement because we've got the data, we change the shape, and we emit it out.
Yeah.
Yeah, and
I mean,
there was
one
an
of, oh,
oh,
sorry, Michael.
I was gonna say one other interesting thing. I mean, I witnessed this at the startup that I was at before, but then I saw it happen at Syncly Broadloom as well, which is being able to emit and flexibly transform allowed them to iterate, right? They didn't have to big bang have the design up front of what the shape was. They could try a shape. Oh, that's not quite right. Let's rewind. We'll do another. Oh, no, that's not quite right. We'll rewind. And oh, this one works. We'll keep that one going.
Hmm. Yeah, that makes a lot of sense. What I think about the evolution of our industry, I remember going way back when, 20 years ago, when I was at TDWI, I interviewed a guy named Dr. Michael Stonebreaker, and I didn't know who he was at the time. And my buddy Philip Rustin was like, "Whoa, you interviewed Stonebreaker? He's the godfather of the modern database." And at that time, he was pushing a mantra of one size does not fit all. And his point was that at that time, relational had won the battle, and every database everywhere was relational. It didn't matter the use case, analytics, operations, whatever, who cares? It's all relational. He said, no, that's not good. You want horses for courses, as Jim Erickson used to say, meaning he had a vertically oriented database called Vertica, curiously enough. And he said, this is better for analytics for a couple different reasons, one of which is the columns all have the same kind of information, so they compress better and you can do some interesting things. But like over the time, you see this evolution. And after that, like, my goodness, the next 15 years, the database space exploded. And there are now like what, 429 different databases or something. You got graph, you've got vertical databases, you have object databases. You had the whole Hadoop thing, which was a very interesting left turn that the entire industry took. And I think we learned a lot of lessons from that. But still, Hadoop is like, okay, what did Robin Bloor say? It's a really slow database. That was his assessment. But
And now it's
Mark, I'll
Iceberg
throw
is a really slow database.
right now it's very slow, but it's like, oh, you can layer it over all this other stuff, and now you can bring it together
Right.
slowly, right? We got about 2 minutes before the next break, Mark. I'll throw it over to you to comment on all that.
It is funny how well, Michael actually got me thinking about how, you know, as engineers, and I'm a recovering engineer still, you always look forward. So you're always taking what you have at hand and trying to build forward without looking back very much. And it's not just the tools, right? You could look at Hadoop and say it's a tool. It's what pattern does the tool enable? And databases enable certain patterns. And one of them is that databases hold their data dictionary inside. And so if you exceed the carrying capacity of one database, you're kind of stuck. Now you need two databases. But what happens? Well, sales live in one and customers live in the other. Now what do I do? I think we're rediscovering that in the so-called lakehouse pipeline architecture where you end up with a data product. I guess that would be the meshy term. Here's the data product for customers and here's the data product for sales. This was the hypercube problem pre, 1988, pre-data warehouse. And you need to enable remixing more easily at multiple levels along the way. I think after the break, we should talk about some of the architectural considerations that happen when you try to construct something that makes reuse or remixing really easily. And I think Josh should have some insights on that.
That is interesting, and I'll just throw out one comment here to close out the segment. I remember when the NoSQL movement began, and first of all, it was no SQL, like we don't need SQL, and then it was not only SQL, right? So like even the definition of that acronym changed. But then what did you see? Hadoop came out, everyone's like, oh, this is going to solve the world's problems, even though, MapReduce is pretty arcane and has certain good use cases, but not many. And I remember scratching my head thinking, this doesn't make a whole heck of a lot of sense. And then what happened after that? They said, oh, yeah, SQL on Hadoop. Let's go ahead and slap a SQL layer on top of this Hadoop architecture. And it's like, it doesn't take a dyed-in-the-wool engineer to figure out that gets a little kludgy, a little complicated. It's going to be not the most efficient system that your engineers have ever cranked out. So we've been through these phases, and it's just kind of funny. We'll kind of map it back when we come back from the break. But things have changed a lot. But you got to get back to first principles, and I think that's what these folks have really done very well. So don't touch it. I'll be right back. You're listening to DM Radio.
Look at the chat.
All right, folks, back here on DM Radio with a whole bunch of database experts talking all about Matterbeam and last mile transformations and file formats. And we had an interesting question come in from one of our virtual attendees here, part of the virtual studio audience, asking how would that be different from a Parquet file? I remember when Parquet files came out. It's a very clever idea because you kind of built in, it was designed for analysis basically. And you had this little, if I recall correctly, you have a little block at the very top of the file that has like min, max, and some basic information to be able to find it and align it with a particular query. But maybe, Michael, I'll throw that over to you.
Yeah, actually, this is one of the sort of soapboxes I get on a lot, which is Parquet is really cool, but it is definitely a physical format designed with a certain kind of query in mind, right? Analytical queries. It is a columnar format. It's designed, it's schemified. It has all those characteristics. And if you want to do analytic queries, great, right? Use Parquet. But if you want to do anything else, if you want to run, transactional things, it's not so good for that. If you want to do other things with that data, it's not so good for that, right?
Right.
So, so I keep pushing back against this idea of the one thing to rule them all, right? The one format, the one system, because it disregards the engineering trade-offs that are made for that system and for what it was designed for, what its purpose was.
Mm-hmm.
Yeah,
Josh, you want to comment on that? Or go ahead, Mark.
yeah, that's definitely the thing is the trade-offs, right? And you think about the history of that, it was, oh, everybody's writing text, and a lot of it was ASCII log text, not even UTF-8 text, into Hadoop clusters. And then people were saying, oh, well, to have to parse that, there's no control over it. What's in that column? Oh, there's a comma missing. Now all your columns are misaligned and you don't have data anymore. You have garbage. So what if we impose some constraints on that? Which, suddenly schema on write, comes back with a vengeance because of all the garbage data we recorded. And then it's like, well, we have that, but but it's inefficient, right? So we need a binary format because what you're doing is taking text and turning it into numbers and then turning the numbers back into text when you query it, and that's stupid. So let's make Parquet. But of course, they went with all of the, sort of Java world data types, but not all of them, and kept it really simple. Here's some integers and here's some floating point numbers, and God help you if you have date times. And then, what happens, like Michael said, is, oh, well, it's not good enough for transactions. Well, transactions weren't important because it was for analytics. But if it's for analytics and you're just supposed to read Parquet by scanning the whole thing, number one, you don't have indexes, so you can't look up one customer without scanning the whole mess. And number two, what if there's a mistake in the data and I need to fix it? Well, then I got to update it. But updates in there are very messy. And now suddenly, while Michael's reading what I'm fixing, he gets the wrong answer. Now what do we do? Because the answer today is not the answer yesterday. Oh crap. And now we have iceberg. Now we have delta. We're just rebuilding the past because nobody's bothering to look at that without looking at what problem are we trying to solve. And in this case, transaction world lives on one side and generates data. Analytics world needs that data in different ways, integrated differently with different views, and has to be remixed, possibly retyped and joined across two different systems from the source, which means you've got to do work on that data, which is how we end up with data products, data marts, and everything else. And so
Mhm.
I like separating those worlds, which is why we had data warehouses. But then you have to take the data warehouse and say, what was it for, and break that down. And it was for the stuff we all agreed on. Everybody says this is what we mean by margin and this is what we mean by product cost. But what if Josh comes along and says, yeah, but I've got two different companies that merged and they measure their product costs differently. Now we need to have product and service costs separated. Well, somebody's got to figure that out. How do you do that? Well, you got to go back to the source data and start over. And I'd kind of like to hear, Josh's opinion on that because he's, the guy who owns the stuff that's trying to do exactly those jobs.
Yeah, we've definitely seen benefits there where we have companies we've acquired that do this a similar thing. So we're working on this right now, actually, where we both are collecting similar data, and we need to basically aggregate that and push it out to a common format so that we can report on it no matter which customer you came, no matter which company you came from originally. And to do that, the other way would be try to figure out all these things, get pipelines going, or dump everything, create views, or a lot of different ways to do it. But with Matterbeam, it's like, okay, we'll just start collecting that stuff. We'll go back in time, collect all of the stuff of theirs. We know what the shape is that it needs to be, and we'll emit it, right? So um, and this the other thing too is like we have sources coming in from everywhere. We've got all kinds of we've got different databases, we've got API endpoints that we hit to collect things. And so all of those get aggregated, and I can't tell you how often we need the same source over and over again. I never thought about it like that, when it's like, okay, you build it from start to finish. But when you go, oh, I've already got that. Oh, we can just pull from here and combine these and spit this out, right? So it becomes so much easier.
Hmm.
Yeah, there's another piece to it too, which I experienced in sort of previous life, but it's okay. You've got this sort of crystalline thing that's the dashboard, the monthly active user, the whatever. With this model, what you can do is say, hey, we need to tweak it in some way. Let's make a parallel view. Let's replay all that data with just these tweaks, with these additions. You don't disrupt the original dashboard. You create the second view, you
Hmm.
migrate over. It makes that infinitely easier. I have this story about when I was in an executive meeting and there was an acquisition, an acquisition came in and the CEO was like, we want to change the monthly active user. And the head of data in the meeting was like, that'll be 6 months. And he's like, how is that 6 months? We have the data, don't we? Doesn't this data exist? And it was not, it's all these pipelines and structured things like that.
Wow.
I used to be an analytics director, and one of the things I think you mentioned a while ago was just what's your backlog? And that was the joke. And we built a data warehouse. I've been an expert. I worked, with Bill Inman. I worked with Ralph Kimball and the Kimball Group. I built like, I don't know, close to 50 of the damn things, and there's always that emphasis on stage one, which is get everything out there, and then people are happy because they've given you the requirements. It's about the reusable data that everybody agrees on. And then you start to get to the smaller requests. Well, the sales guys want to look at this stuff, but sale, according to generally accepted accounting principles, is left the loading dock. But sales to a salesman is when you booked the sale, and the commissions at that company are paid not when it's shipped, but when the sale is actually booked. And so you can't use the exact definition in the warehouse that everybody's agreed to for what's a sale. You've got to go one level below that to define the rule of sale,
Yeah.
right? So you actually need something slightly lower than what would be considered for 99% of actual reporting. And
Yeah,
that's what
I was,
leads to all the backlog.
yeah.
That's
Well,
the thing.
I love you brought that up because that's another inspiration for Matterbeam is domain-driven design, right? The whole idea of one of the reasons why we store the data in this immutable log that's source aligned is that we keep it in the domain of the person that we're collecting the data from. And if you ever get into the domain design driven sort of literature, like the way things are supposed to happen is that domain language is transformed between domains when it's emitted to or used in these other areas. And so we surface that. The idea is I could take that stream of doc things or whatever, and we can coordinate and I can turn it into the sale version that makes sense for my domain, right? In that last mile, instead of having the one universal, data model for everything, which we all know never works, never works. People fight, you get one and it's got all the null fields because nobody can fill in all the fields and whatever. Instead, you let people operate in the domains that they do their work in, and now you can do this translation between them at that last mile.
It's an interesting point, but there is a problem there, and it's kind of why data architectures are, more than two layers, because that there is stuff you have to agree on. I don't think we should get rid of data warehouses because they're for the important stuff you have to agree on or you can't work. But there's a lot of stuff that you don't know that becomes important that needs to be promoted there.
Mm.
And
Yeah.
this part of the architecture, both the fabric to get data where, it's collected and usable, but it's not, or it's collected, but it's not necessarily usable for that final thing. The domains that you're talking about to me are interesting in a different way, which is that from an operational perspective, there's the domain of the generator of data, the order entry system or the CS system or whatever it might be. The domain of analytics is a different domain because it's typically not about task execution and managing a task with local data. It's about managerial oversight of business process that crosses systems, which requires data from more than one thing. And so that is a domain in its own right, but you can't easily meld those two back in operations land. So you always need a boundary zone in between that allows you to do that remixing.
Yeah, absolutely. And it's funny because some people, when I've talked about this, are like, "Oh, so this does it automatically?" I'm like, "No, it does. You still need people, and you need to make those agreements and
Yeah,
move things across. But it gives you the tools to make that
yeah,
easier, right? To be able to replay it, change the shapes, and when things go wrong, when you're like, "Oh, actually, this sales thing isn't what we thought the sales thing was," this immutable time travel thing allows you to heal, right? Which is not a characteristic of most systems today, right? You can go back and
right.
say, let's take a different view and replay that in, and now we've now created a new agreement.
Yeah, for us with the data warehouse, it's allowed us to optimize that so much better. When I joined Broadloom, I mean, I could tell you like 97% of the data in the data warehouse is not used for anything. We're just dumping it all there so that we have it in case in the future we want to run a report on it, right? And so now I'm paying a lot for storage. I'm paying a lot for compute when I go query all that because I may only care about 3 fields in a table. So we initially before Matterbeam optimized that a little bit by creating views and things like that to help with that. But when Matterbeam came on, it's like, wait a second, we don't have to dump everything just in case. We can dump just the stuff that we need, just the stuff that we're actually reporting. So now all of a sudden my compute costs, my storage costs, they're way more optimized. And I'm actually dumping the things that I care about to the data warehouse, not everything.
Yeah, I want to
Yeah.
go
And
back
then you have
to
that remix.
yeah.
Yep,
I
exactly.
want to go back to a point that we were talking about before, which is there's another thing that I mean, once I have the Matterbeam lens, I tend to see things in this way. But um, I think one of the things that's happened in industry is that we've made a lot of decisions predicated on the idea that getting the data is the hard part,
Mm.
right? And that's led us to putting everything into one system, data gravity, all of that stuff, and it forces us to conflate two concerns, which is storing the data and processing the data, right? Which is exactly what Josh was talking about, right? The impulse today is it's so hard to get the data, put it all into Snowflake or Databricks or whatever. And but if you could make it easy to get that data, to get that last mile and put the things that are actually, what Snowflake is good for, put those things in Snowflake when you want to run those analytic queries, it just changes your relationship to the whole data infrastructure.
Hmm.
Right. But
Yeah.
there's a flip side to that too, which is that you want to put data together
Yeah.
most of the time in order to use it. And so you have to do that somewhere. Do you see that having to creep into your product because you've got a whole collection of stuff,
Yeah.
but you use a database to join data? I mean, that is the core function of a database, is to model it for reuse via query.
Yeah.
But you're not a data processing system. You're more of a data collection and movement system. So where do you think that happens, or
Yeah.
does that creep into the product design?
So there's a little bit because we do what I call last mile transforms, right? So we do in-stream processing for things. And so sometimes like customers will say, we need these three things, we need to enrich these three things, and we can do effectively a stream join, right? So take this and fill out these other things and emit this record in that way. So we have this transformation engine, but I always say like we are not a system of query because we've not built our infrastructure, our format, anything like I was complaining about. We've not built it for specific query. I would say if you want to do those joins, you want to do those things, you put them into a relational database, right? Something that is designed for that purpose.
Hmm.
One other thing that I always suggest too is that at least in my experience, in most organizations, there's like a handful, 5 to 10 entities that actually are common across the company. It's usually like customer or, product ID or course ID or something like that. Come up with UUIDs for that because then that makes those joins in those later systems way easier.
Oh, yeah, yeah. That's a good point. Well, folks, we're just burning through the hour here talking to these experts from Matterbeam and, of course, ThirdNature and Broadmoor. We'll be right back. Don't touch that dial. You're listening to DM Radio. All right, folks, back here on DM Radio with Josh Pendergrass from Broadlume, not Broadmoor. Hello, part of Syncly now, and Mark Madsen of ThirdNature and Michael Kowalchik from Matterbeam. We're talking all about this very interesting approach to enabling last mile transformations to do data products on demand, not do so much work up front, just persist all this data in this append only log and then allow people to do what they want with it downstream. And we do have some interesting questions from the audience. I'll throw maybe one over to Michael here. What exactly in the tool makes some genuinely sophisticated data less sophisticated, hence more democratizable?
I'm not sure if I totally understand the question, but the way Matterbeam works is we try to operate on what I call the data primitive, right? And so if you imagine you've got, say, Google Analytics, the primitive would be the event. If it's a database, it would be a row, right? If it's a document store, it would be the document, right? Um, and then what we do is we actually are kind of like turtles all the way down internally. We store that raw data that we're collecting, and then we run a database engine effectively on it to run statistics on it to figure out information about it. So what is the schema? What is the shape? What's the cardinality? What's the distribution of values? What are the things in there? And so once you have that, like you can actually go into the Matterbeam interface and literally look at the schema that we've intuited from the records. And as part of, because one of the interesting things is with this model, we effectively are a catalog as well. So you don't have to add a catalog. This is an emergent property of this model. So you get a listing of all this data. You can look at the data. You can look at the schema of the primitives, and you can even look at samples of it. You can replay samples and look at them
Hmm.
and see information and statistics about it. So when you say sophisticated versus unsophisticated, I'm not exactly sure what they're going for here, but it's trying to find the base thing that you can then remix, as Mark was saying
Well,
later, right?
interesting. Well, you talk about an intermediary format, basically. So you're pulling out all these different systems, putting it in this intermediary format, which someone can then access to do that last mile transformation to populate it in a graph or in a column oriented database or in whatever kind of system you want. I would imagine even some more complex ones. I mean, can you design it and publish it into Salesforce, for example?
Yes. Salesforce is another one of our collectors. We collect those objects. You can publish those objects. Most systems, if you sort of squint, you can find the primitive of what is the thing that it
Sweet.
operates on, right? The Salesforce objects or
Right. Yeah, well, because Salesforce is pretty complicated. That's why
yeah,
it
that
tends to be
that
where, data goes to die, right?
yeah, that system for us was a little bit of a bear to get working. But yeah, it's working. We get that data and what's interesting is because we can remix and we can emit in these different ways. Like Josh can talk about this a little bit, but like there were use cases that they were having where there was manual entry into Salesforce, and then someone would go actually flip flags in Broadloom to like based on the Salesforce data, and then they just emitted it and automated it and had it working using
Hmm.
Matterbeam.
Yeah, I mean,
Wow.
we literally collect data and from multiple sources. So we've got like Mongo, Salesforce, Postgres, where we're taking that data, aggregating some of it, and spitting it out somewhere else. So it's been fantastic. We've got times where we push stuff to Salesforce. We've got times where we pull stuff from Salesforce and use it somewhere else. So
Hmm.
it's made the whole process super easy.
Well, Mark, I'll throw this one over to you. I remember someone saying on one of these shows like 15 years ago, in the IT world, we always believed that one more layer of abstraction can solve all our problems. And in this case, it kind of, at least from a data operations, from a data management or data accessing and usage perspective, it is a very interesting layer of abstraction that allows you to do a whole bunch of different things, right?
Yeah, I mean, yeah, those layers of abstraction are just like putting more planks on top of the ship because water keeps coming up from underneath.
Right.
Doesn't really work.
No.
Yeah, I mean, I would look at it a slightly different way, which is we're trying to deconstruct some of the preconceived ways we build this
Right,
infrastructure, and by slotting in at the right spots, we can put in layers there that actually enable more utility on the data, frankly, right? The ability to
right.
take it and use it for new things.
Hmm.
Yeah,
Cool.
I mean, that's the thing, if you focus on the primitives and you get that piece right, then you can actually build up. And focusing on building an application, a single system, it overtaxes the system. You can't have a Volkswagen Beetle to drive your pigs to market if you're a farmer. It doesn't work like that. And so you have to separate out what is for what purpose. And if you get the basics underneath, then you can layer, right? And so for me as an architect, this both data architecture that you enable by having collector tech that also has the metadata, that knows where it's coming from, that knows where it's going to, and doesn't try to predetermine the target that it has to map into. Like those things all matter. Something Josh said that's kind of interesting too is that, typically ETL tools, data pipeline tools, they were built for analytic pipelines source to target. They never really thought about round trips. And a lot of times that was because it's hard. You're attacking at the database layer, but you need to feed back in at a transaction layer or something like that. And so, that makes tooling difficult and the job of tooling. And there is a ton of we get data from here, we might have to do something with it, but then we need to put it somewhere else. And that element of not purely replication, but movement, it's it's not really out there. If you want to do that with the data replication tool today, like HVR or something, well, I think they're part of something else now, but I would say Attunity, but they're part of Click now. Like I can't remember the name of a single replication tool anymore. But they were great for point-to-point table copies. And pretty much that was it. And so, there's a lot that you can enable if you just adjust the assumptions and the parameters of certain aspects of the tool and the model in which it's deployed.
Yeah, that's actually a
I couldn't have
really
said it
interesting
better.
point you just made. Yeah, so in terms of replication, so to help people understand, all right, why do I use this as opposed to using something else in my toolbox? Well, replication, that's a great use case for you guys, right,
It
Michael?
is. Yeah, replication is a use case. I sometimes call it a little bit like a database replica on steroids.
Hmm.
Uh, because we stream, we keep things in sync, we do those elements of it, but we are not replicating the physical schema, the physical system.
Mm-hmm.
We're replicating the logical system and allowing people to translate last mile into a different physical system.
Mm-hmm.
And that is one of the game changers, right? Being able to use the right system at the right time. One of the early use cases I had for the proto Matterbeam that I built in a previous life was translating between a document store that was across the company into a relational model and doing it as a replication job, right? And being able to do both queries. They became two different views on the same data. So you could, for certain queries, this one made sense, and for certain queries, this one made sense. And it was really like freeing. It was very enabling to be able to do that.
Hmm.
Yeah,
Yeah, that makes.
I
Go
had
ahead.
mentioned earlier in the broadcast about a thing that we were trying to do that was going to take 2 years, and we decided to scrap it. And when we found Matterbeam, we decided to move forward with it. One of them was replacing a legacy system with the newer system, but we didn't want to do the whole thing at once. We wanted to replace screen by screen, function by function. And so with Matterbeam, we're able to go and say, all right, I want you to keep these systems in sync, the legacy one and the new one. We will decide who wins, who's the master system for this function, because that's where it's happening. But there's pieces that the old system needs when we do it in the new system, and vice versa. And also the ability to go back in time to say, oh my gosh, we missed this field. We need to map this over. We're able to just do it, and then it emits it like it was always there.
Hmm. Yeah, that is very interesting. And again, you're enabling people to do what they want in which format they want. Because to Michael Stonebreaker's point, there are times when you want to view data in a certain sense. I mean, Graph, for example, I'm a huge fan of Graph. Graph is very good at understanding relationships between entities. So you look at what Graph has done for social media, for example, for Facebook, LinkedIn, all these guys, they've all got some graph underneath to identify relationships between things. And that's a useful way to look at data as opposed to columns and rows and other ways of sort of organizing matter. And you're opening the door to allow people to do things in different ways down the road. And that's what I find to be really interesting. Well, folks, the podcast bonus segment is coming up here in just a moment. If you want to be on the show, send me an email, info@dmradio.biz. We are booking out the rest of the year right now. We want to know what you want to know. So send me an email if you want to just get on the show or tell me some topic you want to dive into. Obviously, AI is very hot these days. Everyone's talking about AI, enabling AI. What do you need for that? Data, high quality data, lots of different things going on, folks. But again, don't touch the dial. Podcast bonus segment is coming up next. All right, folks, time for the podcast bonus segment here on DM Radio, talking to Mark Madsen of ThirdNature. We've got Josh Pendergrass from Syncly, uh, Broadloom, part of Syncly now, and Michael Kowalchik of Matterbeam. And we got a couple good questions from the audience. One was about storage costs and what does it cost? And then I also want you to comment on how this is different from, for example, Kafka, which also is an append-only log. So go ahead, Michael.
Yeah, the first one is actually kind of an interesting thing where we're early, but our pricing is we don't charge for storage. There is so much more value in the utility of data that we actually charge on the amount of replay transformation that happens on the data.
Hmm.
Um, and so part of what makes Matterbeam possible today, because I had built previous systems that were similar in spirit to Matterbeam before, but Matterbeam is fully cloud native. And part of what you can do is store things in object store, and people just haven't internalized how cheap object store has become. If you're smart about how you store it in the life cycle, you can store a petabyte of data in Glacier long-term storage for $1,000 a month. For most of our customers, their data sets are not petabyte scale, right? Even with the full like streaming like fact stream model. And so if I've done the back of the envelope calculations, like if you actually charge on what's valuable to the customer, we don't even want storage to be part of the conversation. Like we're going to store this because having
Wow.
it is more valuable long term than nickel and diming people on the storage costs. We used to talk to people. One quick story: we used to talk to people when we were doing customer discovery around Snowflake, and we're like exploring. We're like, "Oh, tell us about your Snowflake bill." Oh my God, the Snowflake bill is like killing me. And what's the storage cost? Oh, I don't know. It's a rounding error. I'm like, why are they charging for storage if that's the model, right? So anyway, that was an interesting piece there. So the second question was Kafka. Spiritually, there are some similarities, at least at the sort of streaming log layer, I guess. Kafka is much more low level, right? Kafka is bytes on a log stored in a sort of traditional server model, big iron kind of thing. Um, I've built a lot of Kafka systems, I've used a lot of Kafka systems. Having it interoperate with other things requires a ton of upfront work to enforce schemas and enforce shapes and enforce all sorts of contracts and things. Otherwise, you just get bytes on a wire that one team can use or two teams can use, but no one else can use. So Matterbeam is one layer up from that, or a few layers up from that, where we're very opinionated. We run these database engines to do statistics and things like that to create these common record formats. And so it's not just binary bits, any kind of binary stuff into a log. It's our format that allows us to do this rapid translation between that format and target systems. Um, so a lot of people ask me, how is this different from Kafka? I would say you could build a Matterbeam using Kafka as a primitive, but you're going to have to build a bunch of stuff to make it
Mm,
do what we do.
mm. That's wild. And I have heard those stories about Kafka too. And of course, it's also Java, right? So when you get these really big environments, there are all kinds of problems. And that's why you have Java experts showing their technology at the different conferences. So things are changing. Then, of course, what happened? Red Panda came along and rewrote it all in what, C sharp or something, or C plus plus to
Yeah,
kind of.
everyone keeps trying to take runs at that. Warp Stream. Warp Stream is probably closer philosophically to us because Matterbeam has moved to this fully cloud native model. So we use cloud primitives. We use the cloud as the computer, which just changes a
Hmm.
lot of how you build a system like this, right? Like I would say, if you look at the source code for Kafka, it's like 80% of it is process management, replication, leader election, all this stuff. The interesting stuff is like 25% because you're dealing with spinning disks in a traditional server
Right,
system. If
right.
you go cloud, all that replication stuff, if you take it on, is basically handled by object store, right? You get 11 nines of durability and whatever it is, 5 nines of availability, and the replications at that level. And so all that complexity moves away from what we have, right?
Yeah, wow. All right, we got just 3 minutes left. Closing comments. Mark Madsen, I'll throw it over to you. I just love that these folks have deconstructed the architecture writ large and thought about how you would reconstruct that on demand. That's kind of how I view it. But what are your thoughts, Mark?
Yeah, I mean, when you change the tools and the tool capabilities, you change what you can do with them. So you change the architectures, which enables new things because architectures enable, but they also constrain, right? The whole point of an architecture is, as an architect, you make trade-offs. And some of the ones that we made, we gave up or we chose one aspect of a principle. Like in coding, there was the principle of loose coupling, right? And data, we lost it by binding all the data together in one place. Or reusability of code was captured by functions and libraries. In data, that was more built around schemas, but it ended up being trapped inside a single database. And the other, I think the one that Michael's gone on about quite a bit is premature optimization. A schema or persisting a schema is a choice at a particular point in time in a, like in a pipeline. But you can take stuff from a pipeline and then carry it further and do further processing on it. And so you could persist at any point. So there's always these kinds of trade-offs. And one of the big ones for me is that I can do something instead of having to do everything. And that was
Hmm.
always my complaint about the warehouse and why I diverged substantially from that particular architecture circa 20 years ago.
Hmm. Wow. Final thoughts from you, Josh.
Yeah, I would say I think my statement was, first I didn't really understand the immutable log, and now I said you can pry it from my cold dead hand. So yeah, I can't say enough good things about it, and especially the business value. I mean, I see it from the cost perspective and how many less resources we have. But the funny thing is now I get from the product team, anytime there's data involved, the first question they ask me is, can we use Matterbeam and make it go faster? So,
Wow.
everybody kind of sees the business value there.
That's a pretty good closing quote, but final comments from you, Michael Kowalchik, 1 minute.
No, I mean, this has been a super amazing conversation, really, really helpful. For me, what I love to see is the Josh situations where, the vision, you start with a vision. I think this is going to unlock all these problems and solve all these things. And to actually see it happen is super gratifying. Like in our early customers, we're seeing it more and more. When I built it, the prototype, I had a data scientist come to me and like basically tackle me in the hall. And she's like, "Did you build this thing?" I'm like, "Yeah." This got me data in 30 minutes I've been struggling to get for 3 months.
Wow.
Like that's what this is about.
That's the happy path, right? There's the happy path and the unhappy path, and you're enabling the happy path for data users downstream. Well, folks, look these gentlemen up online. Michael Kowalchik, Matterbeam, Mark Madsen, ThirdNature, and Josh Pendergrass from Syncly and Broadloom. Not Broadmoor. I got it wrong at that one segment. But we'll talk to you next time, folks. You've been listening to DM Radio.